Good morning. It's a pleasure to be with you today to talk about Silvopastures and Southside. I apologize I can't be with you in person. I'm on my way to the Appalachian Grazing Conference up in Morgantown, West Virginia. I'd like to thank Cynthia for inviting me to come talk to you today about how silvopastures may fit into grazing systems in Southside, Virginia. I'd also like to draw attention to my co-author, Dr. John Fike. Dr. Fike is in the Crop Science Department at Virginia Tech, and he's kind of our leader for this statewide silvopasture effort. These two gentlemen were my first exposure to silvopasture, and that's Dr. Jones on the right and Mr. James Bennett on the left. And when I came to Virginia Tech in 2000, Dr. Jones gave me a document that was a agroforestry plan for the research station. And as part of that agroforestry plan, silvopasture was included. And then he took me down to Red House to meet Mr. Bennett, and that was certainly a memorable visit. We talked about land clearing in clover and fertility and beef cattle and a little bit about silvopastures on that visit. And that was my first exposure to this idea of incorporating trees and forages into a system. Now, things can always be a little bit deceiving, like this photograph where it looks like Dr. Jones is as tall as Mr. Bennett. When we step back, we can see Dr. Jones was actually standing on an old pine stump in an area that had been clear cut and seeded to forages. I'd like to start out and talk a little bit about what silvopasture is and what it isn't, and give you an idea of how it might fit into grazing systems in the south side of Virginia. Silvopasture isn't new. It's been around for a long, long time. Sometimes it's really well managed, and sometimes it's not so well managed. Silvopasture isn't just simply turning cows into a wooded area and letting them have at it. It's really incorporating management and grass and trees all together into a system. It's not a single tree or two in a pasture where animals tend to congregate underneath. As you can see from this photograph, the vegetation is non-existent underneath this tree. That tree also serves as a nutrient magnet within that grazing system, so those animals are drawn to that tree for shade. And then they deposit dung and urine there, and over time they build up nutrient concentrations in that area of the pasture. When we manage a silvopasture, we'll have an even distribution of shade across the entire pasture area, and that will help with better nutrient distribution within that grazing system. What silvopasture is an intentional integration of trees, forages, and livestock, and it's intensively managed. So it's not just turning animals into that pasture with trees, it's actually practicing rotational stocking underneath those trees. It's managing fertility underneath those trees. It's managing livestock underneath those trees, and then it's managing those trees as a valuable part of that whole system. The interesting thing about silvopasture is it has two economic time frames. The first time frame is the forage and livestock. That's a short-term economic time frame. They're going to return revenue to the operation in the short term. The long-term time frame is the trees. And it's a little bit hard for me to get my head wrapped around that, where we have a resource that's not going to return anything to the system for another 25 or 30 years. But that's the beauty of incorporating both of those time frames into one management area. Now, there's lots of benefits of silvopasture, and we'll talk about just a few of those. And this is from a publication by Hamilton. One is increased cool season forage growth. One of the things that can happen underneath a silvopasture is that we modify the microclimate, so that climate underneath those trees will be moderated in our part of the country during the summer months. So we'll have the shade, and we can potentially increase cool season forage growth underneath those trees by shading those forages. We can have improved or sustained tree production within that area. And again, we're managing those trees not just for a timber harvest, but for a very high quality timber harvest. Shade for livestock. We're going to talk more about that in the next couple slides. Can improve wildlife habitat. Wildlife can be an important part and even an economic or profit center on a farm if it's well managed. We have reduced soil erosion, improved water quality, because we're maintaining a cover on that land, a well-managed cover. It's hard for me to believe that there's anything that could be a greater aesthetic value than a well-managed silvopasture. It almost looks like a park. And that certainly benefits the landowner and also people that are interested in agriculture that are just driving by. And then we have improved economic performance from the whole system. And we're going to talk about that in a few slides. When we look at livestock production and we think about our animals, all of us that have animals in the south side of Virginia knows that during the summer months they appear to be under heat stress. And that's kind of where this whole idea of silvopasture and shade for livestock kind of comes together. My good friend Brian Campbell always likes to kid me about using this slide. He says that you have to go back 60 years in literature to find anything that says that shade improves livestock production. And in my defense, I'll say that there hasn't been a lot of shade studies actually on pastures. Most of the shade work has been done in feedlots. And this is really a kind of a nice study. This compared natural shade, artificial shade, and no shade. And looked at cows and calves. And when we look at the calf data, we gained 1.85 pounds per day when we had natural shade, and that would of course be trees. And we gained only 1.2 pounds when we had no shade. So significant impact of shade over a 4-year period in this study. Now to be fair, there's lots of other studies, mostly done in feedlots, that show no impact of shade on animal production. So for Brian, I found another study that was done in the early 2000s that looked at shade in livestock production. And this was done in a feedlot situation. And this data was taken over a 131-day period from when those animals entered the feedlot until when they left. And what they found was that the final weight of animals that had shade was higher, average daily gain was higher, dry matter intake was higher, feed efficiency was better, and respiration, which is a measurement of heat stress in animals, the more you're panting or more breaths per minute, indicates a higher level of stress in those animals. That was lower for animals that were in the shade, as you would expect. So, again, not all studies show this. There are other studies that show no difference between shade and no shade. This was a really nicely written article that was in the Temperate Agroforester. It's kind of a newsletter. And it discussed shade and livestock production in trees and silvopasture. And really a well-written and well-balanced article. And a couple things that they pointed out is that it's just not temperature that impacts heat stress in livestock, but also humidity. And when we think to our summer months in July and August in the south side of Virginia, we've got many days where we're 95 degrees and 90% humidity, and that is really a great combination for heat stress in livestock. They also point out it's just not solar radiation causing heat stress. It's also metabolic heat, or heat being generated from within that animal, and that involves the rumen and the fermentation going on in the rumen. And even if we put shade over that animal, we still have that heat being generated. And then in our grazing systems in the south side of Virginia and throughout the tall fescue belt, which ranges from Virginia to Missouri, we have tall fescue toxicosis. And everybody in this room already knows that one of the things that tall fescue toxicosis does is increase the body temperature of the animal. So we have high temperatures in the summertime, we have high humidity, and then we throw tall fescue toxicosis in on top of this, and that just exasperates the heat stress during the summer months if we're grazing Kentucky 31 with a toxic endophyte. Now, what these authors conclude is that shade doesn't always impact animal performance, just like Brian Campbell tells me, but it's most likely to impact animal performance under sustained extreme heat stress. And I would argue in the south side of Virginia, we've got some sustained extreme heat stress during the summer months in July and in August. And it would be good to get those animals out of those pastures with no shade in the pastures. And I'm not telling you that we need to go back and replant our entire farm into silvopasture, because I don't think we need to. But it would certainly be nice to have some silvopasture that would be a good place to go during the summer months with those animals that are under heat stress. And in the end, I personally think that this may not even be a production issue. I think this may be an animal welfare issue. As we get more connected with cell phones and YouTube videos and so on, we don't want to show a bunch of pictures of animals under extreme heat stress during July and August. They're out in the middle of the pasture with a black coat on, and I just don't know how we could have chose a worse color for animals in the south side of Virginia, but we certainly did choose black. I think that the welfare issue is going to be even bigger than the production issue. I'd much rather show a consumer a picture of my livestock grazing underneath a Silvopasture than standing around a mud hole trying to cool itself off in the summertime. Now, whenever we talk about Silvopasture, we like to talk about what we call the land equivalency ratio. So basically what this says is that we can use land for different things. We can use an acre of land and have pasture and livestock on it, or we could plant it in pine trees and let the pine trees grow. Whatever we choose to do, that's 100%. And so all of a sudden we take that same land unit, instead of using it for just pine trees or just livestock production, we use it for both in the Silvopasture situation. And when we do that, we're not going to get as high a production for trees, and we're not going to get as high a production for forage and livestock, but the sum of those two are going to be greater than 100%. And that's the whole concept behind Silvopasture. So a well-managed Silvopasture will actually be producing more per unit of land area than we could separately. And that's kind of what that green bar shows. When we combine the two, we have a higher land equivalency ratio, or a higher output of that whole system per unit land area. Now, one of the issues that we deal with, and that we've talked a lot about in the last number of years, is fencing animals out of water. Been a lot of cost share programs that have focused on this. And you've got to ask yourself, is it putting a fence around this water source? Sure, it takes care of the immediate water quality problem, but are we addressing the underlying problem that's causing these animals to go to this water? I mean, why are they going there? They're probably going there because they're under heat stress. They're grazing toxic tall fescue. They're hot. They're trying to cool off. They're going into the water. One of the things that we haven't talked about is what impact does it have on animal performance when we take them out of the water and take their chance to get in that water to cool off? Does that have any impact on animal performance? I don't know. I don't think anybody knows that for sure. But that's something that we have to consider. So the point I want to make with this slide is that simply putting a fence up around our water sources isn't getting at the underlying problem of those animals being under heat stress. So another thing that we know is that we incorporate non-toxic or novel endophyte tall fescue into a grazing system. Animals tend to graze more when it's hot out than animals on toxic tall fescue, and this picture does a great job of showing that. The animals on toxic tall fescue, and you can see they've got GPS collars on them, are mucking around the water. They've made a little mud hole around the waters. And the animals that are on non-toxic fescue just across the fence line are grazing. So replacing toxic stands with non-toxic may be a solution to help alleviate heat stress during the summer months. Not a complete solution, but part of the solution. But we get to places where, for whatever reason, we can't replace the tall fescue with a novel endophyte. And that's an issue, and whether it's because it's on a rented farm and we can't make that investment, or whether the terrain keeps us from doing that because it's so steep that we don't want to take the environmental risk of getting rid of that sod. That's a big challenge. So providing some shade with Silvopasture may help to alleviate heat stress related to tall fescue toxicosis. It kind of makes sense. And perhaps even make cool season forages more competitive, other cool season forages more competitive with tall fescue. So some work that Gordon Jones is doing at Virginia Tech now is showing that orchard grass persistence may be related to heat stress in that forage crop. Maybe modifying that microclimate underneath those trees may help orchard grass be more competitive in our region of the state. Lots of questions to be answered and few answers to be had at this point in time. All right, so I want to just take you through some ideas about establishing silvopastures. I'm not saying they're right and I'm not saying they're wrong, and there's lots of different ways that we can establish silvopastures. But what I want to do today is get you to think about how you might incorporate silvopastures on your farm if you want to. You may decide that I don't want to. So the first one is taking an existing stand and converting it into a silvopasture. So we would thin an existing stand and then plant grass underneath it. That's the concept behind this one. And we're demonstrating that here at the research station. We hope you can come back this summer and take a look at our progress. So when I was doing this, I brought this dream team of silvopasture experts together from several states and within Virginia. And I said, all right, here's my stand. Put them out in the woods. How many trees do I leave? Guess what? There was silence. I had a hard time getting anybody to commit to how many trees to leave. We had one person in our group had a graph with 3 different axes on it and wanted to use that. And I think that would be okay, but how practical that is, I don't know. So anyways, after much discussion and meeting and talking with different people, kind of what I came up with was that we were going to remove 50% of the basal area. So whatever was there, basal area is we cut that tree off, the area of that stump. We're going to remove 50% of the basal area. And we're going to try to leave trees that have some growth potential left. I think the ideal situation, if we were going to do this and I had more time, would be to do what my local forester, Kirby Woolfolk, which is a great resource for you all. If you have questions on Silvopasture, especially on the tree side, there's 2 great resources in Southside that I know of, and that's Kirby Woolfolk, and he's stationed in this right here in Nottoway County. And then we have Miller Adams, who's a forester down towards Charlotte Courthouse. 2 excellent resources, and I would encourage you to use those 2 resources to your full ability. I'm not a forester. I don't even pretend to play one on TV. I'm a forage guy. And I'm just trying to put all these pieces together and figure out how to establish silvopastures in this part of the state. So the ideal situation, which Kirby came up with, would be to go into that existing stand, do a hard commercial thinning, push it just a little bit, let it sit for 3 to 5 years, come in and do a second thinning to get it down to a density that we think we can grow grass underneath it. That's the ideal situation. That 3 to 5 year period gives us trees a chance to increase their stem base or basal area so that they can support a larger crown. If we thin too much, we really open that stand up to wind damage, ice damage, and even to a very rapid growth in that crown of that tree, more rapid than the base of the tree can support. And sometimes that will actually cause the tree to bend over, break the water column, and die. So that's a real issue that we need to think about when we think about thinning an existing stand, not to thin it too much. When we harvest or thin that stand, we've really got to think about mitigating damage to the trees that are remaining, not just to the stem base of the tree where it gets skidded up, but also to the root system and also to the crown of the tree. So when we're removing trees, if we have an operator who's not careful, we can do a lot of damage to the crown of remaining trees. Somehow we've got to get those stumps out that we leave. I've got colleagues that think that we can leave the stumps and just work around them, and maybe we can. I don't know. But it's going to be awful hard to get soil amendments on if we don't somehow get rid of those stumps. In our project, we're taking a mulcher, I'll show you a picture of in a minute, and just mulching those stumps to the soil surface, minimizing soil disturbance within the pasture area. And it's going to allow us to get equipment in there to seed, to put fertility on those pastures and to maintain that grass afterwards. If you leave those stumps, then you can't clip those pastures. It's hard to get in there to spray anything. It's going to be hard to seed in there. It's going to be hard to get fertility in there. So somehow we've got to get those stumps down to the soil surface. I don't think we want to do a lot of pushing and raking and so forth. I think will cause damage to the remaining trees. I think mulching may be our best effort, but I don't know for sure. That's why this is research. So we got to get lime, P, and K to it, and we'll talk about the fertility needs in a minute. This is the mulcher that we used on some other areas, and essentially we get in there and it just kind of eats up everything on the soil surface. We're going to have to be careful not to damage the root system of remaining trees. Really, our goal is just to get those stumps down to a level where we can get them over them with equipment. When we took soil samples, we did a very detailed soil sample of the area, that we're working with at the research station. I'll show you those details at the end of this presentation. But we essentially have a pH of around 4.85 or so. And we have a phosphorus requirement of 200 pounds or more of P2O5, essentially no phosphorus in these forest soils. We have a potash requirement of 150 pounds, so that's that low plus range. And then we need some nitrogen to get the forage crops up and growing. And as the residue breaks down, the microbes in this system actually can tie that nitrogen up, so that's something else we need to be thinking about as we make nitrogen recommendations. So, at the end of the day, if we do everything with commercial lime and fertilizer, this is what it's going to cost in terms of nutrients per acre. And I may be a little bit on the high side, but these are current fertilizer prices. I'd say it's going to cost you between $400 and $500 pretty easily to get that soil up to a level that's going to sustain adequate forage production. That number is almost cost prohibitive. When we figure in land clearing, getting those stumps down, and then $500, $400 or $500 of soil fertility, I mean, it can be pretty expensive to bring this land into production. Now we'll have people say, well, I'm just going to spread some grass seed out there. I don't think that's going to work real well. I think in order to have adequate forage growth, we've got to have a base level of soil fertility. That's going to be really, really important long term. So this real minimum input is probably not going to be real successful long term. You're going to have a lot of broom straw and a lot of undesirable plant species within the system. So what I want to do now is take a look at some different approaches to building soil fertility within these silvopasture systems that are going to allow us to get forages established and help get optimum productivity. The first one is lime stabilized biosolids. This is some biosolids that we used here at the research station when we brought some land into production. And this is a nutrient profile. 25 pounds of PAN, PAN stands for plant available nitrogen, 35 pounds of phosphate, and 5 pounds of potash per ton. So as with all biosolids, potash tends to be very low in the biosolids. So we're probably going to need some additional potash fertilizer with biosolid use. And then each dry ton, and this was on a dry ton basis, each dry ton also had 0.2 tons of lime equivalent per dry ton. So in this first scenario, we apply 2 dry tons per acre. Why did I choose 2 dry tons? Because I talked to the biosolids people, and if we establish a pasture, the allowable amount of plant available nitrogen is going to be 100 pounds per acre, and that's going to limit biosolid production. Okay? So if I take 2 tons and dry tons and I apply 100 pounds of plant available nitrogen per acre, I'm going to get about 140 P2O5. Remember my requirement's about 250. And I'm going to get about 20 pounds of potash. And I also bring 0.8 of a ton of lime per acre. So the value of those nutrients that we're bringing in that biosol is about $150 per acre. But we still need some P2O5 to get us up to the about the 250 pound range. We still need potash, 120 pounds, and we still need a significant amount of lime to get us from 4.8 up to around 6.5. And when we add the cost of those up, that's going to be about $300 per acre. So a total fertility cost, if our biosolids are free, is going to be about $300 to bring this land into production. So that's about $150 cheaper than commercial fertilizer. So let's do this same calculation again, same biosolids, but this time we're going to use 200 pounds of plant available nitrogen. That'll be 4 dry tons per acre. Where did I come up with 200 pounds at? 200 pounds is the allowable application rate for a thinned pine stand. So we don't really know yet where where silvopastures are going to kind of come in. Are they going to be 100 pounds of plain available nitrogen with pasture, or 200 pounds with a thin pine stand? They're kind of something in between those two extremes. So we'll assume that we can get this through the legal hoops and apply 200 pounds of plain available nitrogen. That's going to give us 280 pounds of P2O5, 40 pounds of K2O, and 1.6 tons of lime per acre. That's going to be a value of nutrients of around $300 per acre. So we'll still need a little bit of potash, and we're still going to need 2.5 tons of lime. So our total fertility cost is going to be around $160 per acre if we can use the 200 pounds of plain available nitrogen rate for the biosolids. Very, very considerable cost savings with this route. And I would encourage you, if you're going to bring land into production, I would think about using biosolids on it. Let's look at broiler litter as an alternative to commercial fertilizer. This is a nutrient profile: 45 pounds of plain available nitrogen, 50 pounds of P2O5, and 55 pounds of potash. Now, as with the biosolids, any of these organic sources are going to vary depending on where you get them from and what day of the week it is. So you got to have a test to let you know what's in the material you're actually applying. So it could be higher or lower than this, but these will be in the ballpark, these estimates. So in this scenario, we're going to apply 2 tons at establishment and 2 tons that following season for a total of 4 tons per acre. We're going to have 180 pounds of plain available nitrogen, 200 pounds of P2O5, and 220 pounds of K2O. And that's going to be about $300 worth of nutrients per acre. So we're still going to need a little bit of phosphate and then lime with this scenario. And our total cost is going to be $388 because we have to figure in about $40 a ton for the 4 tons of broiler litter. So cheaper than commercial fertilizer, but still more expensive than the biosolids. The last option I want to talk about is pelletized biosolids. Sometimes we can get these, not always, but sometimes they're available. They have a nutrient profile of 40 pounds of plain available nitrogen, 120 pounds of P2O5, and 12 pounds of K2O per ton. They're dusty to apply, as anybody that has used these know. So we're going to apply 2 tons per acre, and that's going to give us 240 pounds of phosphate, 80 pounds of plain available nitrogen, and 24 pounds of K2O. We're looking at somewhere around $185 of nutrients per acre from 2 tons. We still need some potash, and we still need some lime. And when we figure the cost of these pellets in, and I figured these at $55 per acre per ton spread. Maybe you can get them a little bit cheaper, I don't know. But I would figure $40 to $60 probably. And we're going to need a little bit of potash left, and a little bit of potash. And then we're going to need some additional lime, of course. And we come out with a cost of around $362 per acre, so very similar to broiler litter. So this table just kind of sums everything up, and it's got some pros and cons of each one of the fertilizer sources. Of course, conventional fertilizer, that's going to be the easiest to get and the easiest to get applied. And it's fast acting. So, and it's going to be the most expensive. If we use biosolids, they tend to be less in cost. They don't have any potash though, so we got to still put some potash on them. We're going to need more lime, and they'll have a slower nutrient release profile. So it's not like putting commercial fertilizer on where everything's immediately available. They're going to kind of mineralize over that first growing season and release the nutrients a little bit slower. Bad or good, I don't know. But it is what it is. Broiler litter, again, that slow nutrient release, has potash in it. It's one of the benefits of broiler litter. Has no lime value, and of course availability can be an issue. Lots of different people looking for broiler litter now. Pelleted Biosolids, Class A fertilizer product, so you don't actually need a permit. Supply has always been an issue. Sometimes you can get them, sometimes you can't get them. No potash value, no lime value, slow nutrient release, and you've got to buy them. So all in all, if you can apply 200 pounds of plant available nitrogen as a lime stabilized biosolid, that is by best your best option. So let's talk about a second scenario, and that's turning an existing pasture into a silvopasture. We've cleaned up some land here at the research station and that was in forest, and to me the idea of planting land back into those trees that's a tough sell for me, because it's a lot of work to clean land up if you've ever done it. Could happen, but I think mostly what will happen is that we're going to go from forested land into silvopasture. So since we're already doing a good job managing our pastures, you've been coming to these meetings and doing what I've been telling you over the years, I'm going to assume you've got adequate soil fertility. The first thing we need to think about is that what kind of configuration do we want the trees planted in? So do we want rows? Do we want multiple rows? How far do we want the trees apart? What direction do we want the trees planted in? We've got to control grass strips for the tree planting, and usually that's 4 to 6 feet wide for each strip of trees. And then we want to scalp or peel back that sod, and they've actually got a tree planter that does that, the forestry department does. And Miller or Kirby would be good to visit with about that. And then we've got to think about, after we establish those trees, we're going to have to manage the forage or the grass component as hay for 2 to 4 years, or if we decide to graze it, we're going to have to protect those trees or rows with maybe temporary fencing for 2 to 4 years until they get big enough that they can handle a little bit of livestock pressure. So I want to spend just a few minutes talking about some row arrangements. And the first one, and one of the most popular ones, is single row arrangement. And that's where we have 8 to 12 feet between trees, and then somewhere between 16 and 30 feet between rows. The wider row spacing tends to favor forage in this particular configuration. And again, this is one of the recommended arrangements. Another recommended arrangement is the double row spacing, and that's where we have 8 to 10 feet between trees within a row, and then 8 to 10 feet between rows within a set. And then between the sets, or those multiple row plantings, we have about 20 to 40 feet. And again, the wider row spacing between the sets of trees tends to favor forage production. It's also nice for equipment operation versus a kind of the design that we talked about first, where we thinned an existing stand. And then there's 3 or 4 row arrangements, and again, 8 to 10 feet and 8 to 10 feet between rows, and you could have 3 or 4 rows. This is not one of the favored configurations in the Silvopasture manual for the southeastern United States. And again, I'm not a forester, but what the book says is that the middle rows tend to produce poor quality timber. And one of the goals of Silvopastures is to produce a very high quality timber product. So anyways, we again would have those multiple sets of rows with 20 to 40 feet between them. The last configuration that I wanted to talk about was a block or equidistant planting. So we would start off with a wider than normal spacing between the trees, maybe 12 or 15 feet. And this planting is going to tend to favor timber production. So we plant a solid planting, but we just space the trees out more. And then we'll come in and thin them in time. This is going to tend to favor timber and make it more difficult to get forages established between the rows. All right, the last approach that I want to mention today is taking a clear cut to a silvopasture. And again, if we're going to plant a silvopasture, we've got to get rid of the debris around the soil surface and get the stumps mulched down or cut down to a level where we can get across them with equipment to get our lime and phosphorus and potassium on. Again, we have to go through this whole row spacing and orientation thing again and figure out what kind of configuration we want to plant the trees back in. Then we need to plant trees and seed forage, and we want to manage again this hay for 2 to 4 years and protect our trees with temporary fencing for 2 to 4 years if we're grazing. Now, one of the things that we want to do after we establish these trees is manage them. And there's a couple things that we're going to do different than we would in a conventional tree planting. The one is pruning for high quality saw timber. And I know everybody says, oh my God, I can't do that. You're going to have a lot fewer trees per acre for one thing. But really one of the objectives of this whole silvopasture is really turning the management up a notch or two within the silvopastures. And to get a high quality timber product, we're going to have to prune the side branches. Now remember, if we have a 1 or 2 row configuration that was recommended by the Silvopasture manual, you're going to have light coming in on the side of those trees, and you're going to get branching on the side of those trees. So we're going to have to come in when those trees are 15 to 20 foot tall and have a stump diameter of about 5 inches and prune those branches and leave about a third to half of the total height of the tree as crown. And we're going to repeat this until we get a stem base that's 18 to 32 feet without any branches. And again, the manual says this is best done in late winter when the trees are kind of dormant. The other practice is that we're going to have to thin the stand. So as the silvopasture develops, the trees are going to grow and they're going to start to shade the grass more. So what we want to shoot for is if we have a warm season grass, we want a 25 to 45% canopy. With our cool season grasses, we want a 40 to 60% canopy. So every 5 to 7 years, depending on how many trees we initially plant, we're going to have to go in and cut some of those trees out to keep that canopy within the specified range. I just want to point out that a lot of this information came from this publication. It's called Silvopasture Establishment and Management Principles for the Pine Forest in the Southeastern United States. Very good publication, very practical, easy to read, and available online at this address. If you're interested in silvopasture, I'd encourage you to download it. It's as a PDF, and you can print it out, and it's pretty easy to read. It doesn't have all the answers, but it's a good start. I want to spend the last part of my presentation talking about some work that we've started here at the research station. And we got a grant from the NRCS to establish silvopastures here at the station. It's a Conservation Innovation Grant. And the title of the grant was Establishing and Managing Pine and Hardwood Silvopastures in the Mid-Atlantic region of the United States. And as we were getting ready for this grant and applying for this grant, we actually brought together a group of people from different places. And I've always thought the more diverse you can make the group, the better ideas you get in terms of actually putting things into practice. And we've got people in this group from the Department of Forestry, from Virginia State University, from the NRCS Technical Center in Greensboro, North Carolina, and our local forester, Kirby Woolfolk, is right in the middle there, with J.B. Daniels, who's another great resource for silvopastures in this part of the state. And J.B. is a state grassland agronomist for the NRCS. And he lives in Amelia, Virginia, so he's close. So the objectives for this grant was, one, to demonstrate the establishment of pine and hardwood silvopastures, demonstrate the use of managed grazing in silvopastures, and to provide educational opportunities for producers and livestock producers and agricultural, forestry, and conservation professionals who work with livestock producers. So they can come here and see what we've done right and what we've done wrong, and try to figure out how to implement this at the farm level. So we of course have an experimental design. I'm not going to bore you with that, but we've repeated all of our treatments twice. And our treatments are thinning an existing pine stand and establish grass underneath it, then an existing hardwood stand, establish grass underneath it, clear cut and replant to a silvopasture configuration using pine trees, and then clear cut and go straight to pasture. And that would kind of be our control block to compare other things against. And this is our layout. We've got 40 acres in this project. And we divided that 40 acres up into 8 5-acre blocks. And we established a sampling grid within those blocks. So we've got permanent sampling points, about 1 every 0.42 acres, and they're in the green on this map. And those sampling points will come back year after year after year and sample different things that I'll tell you what they are in the next couple slides at each one of those points. And that'll give us a way to trace differences that we see between, not only between treatments, but over time. So what we did this last year was kind of get what I call a snapshot of the whole ecosystem. And so I'm looking at a lot more things than just agricultural related. We're looking at things like the insect population that existed in this forest before we changed management. We're looking for macro-invertebrates like earthworms. We're looking for soil microbes. We're looking at carbon and nitrogen in the soil. Looking at the leaf litter on the soil surface and insects within that. We're looking at the tree community and the understory community. We're looking at nematodes in the soil and other things as we go through. But basically, we're trying to take a picture of that whole ecosystem, and then we're going to track how it changes as we go from a forested area into a pasture and into silvopasture. We collected last summer a very intensive insect sampling. We did daytime flying insects, nighttime flying insects. We sampled macro-invertebrates or earthworms and centipedes and so forth in the leaf litter. And then we also took and dug a soil pit and went through the soil and separated out macro-invertebrates in the soil. Very, very tedious work. And I say that, I posed for a picture, but mostly my students and Dr. Sempner, our entomologist here, really did this work. It was a lot of work to sample for invertebrates in the soil. So our initial results, and we came in and we did a very detailed survey of trees. Or some students from forestry came down and sampled our forest stand before we did anything, and they came back this winter and did it again after we thinned our stands. And they found oak species. In the hardwood area, oak species were the dominant species, and they had a basal area of about 120 square feet. In the pine area, loblolly pine, as you would expect, and had a basal area of about 382 feet per acre. When we looked at soil chemistry at each one of those points, we took soil samples, and our average soil pH was about 4.9. It ranged from 4.4 to 5.6. We had a soil phosphorus of 2 parts per million. That's very low if you're not familiar with that 2 parts per million. So essentially no plant available soil phosphorus. And in a range of 1 to 24 parts per million. We had a potassium of 28 parts per million, and that's in that low plus range. And range from 15 to 54 parts per million. And then we had nitrogen in the soil of, on average, 0.04%. And we had carbon in the soil of about 2.46% on average. So very detailed sampling to establish that initial baseline, and then we'll track this over the years. One of the things we did that was kind of unique was we measured total microbial biomass. And if you asked me to recite the procedures for doing that, I couldn't do it. We took the soil samples, we took them to a microbial specialist on campus, and he actually measured the total microbial biomass and came up with a mean biomass of 28,000 pounds per acre. It's pretty amazing when you think about that. That's 14 tons of biomass per acre. We measured nematodes in our soil samples. We had 15 different species of nematodes, of parasitic nematodes, and then other free-living nematodes in the soil. We sampled the insect community. Our most abundant ground-dwelling insects were camel crickets, pill bugs, harbistmen, flatback millipedes, and field crickets. We caught those in actual little traps or cups that we put in the soil, and they just kind of wandered into those cups, and they were collected weekly and counted and so forth. So after we got that done, our our loggers moved in, and we had gone through with a local forest professional, told him what we wanted to do, and had him mark the trees to leave within there. We tried to leave trees that would have some growth potential. We tried to leave trees that were equally spaced within a block, and we targeted 50% basal area to leave. And we came very, very close to that. Did a great job marking the trees. The loggers did a great job harvesting the trees. We helped the loggers do that by putting in our contract that any tree that was damaged severely or cut when it shouldn't have been cut they would have to pay us 3 times the value of that tree. So it was a little bit of encouragement. And the operators were really good. Very little damage to the trees. And I didn't see any trees with blue paint leaving, so I feel pretty confident that we got the trees harvested they should have and left the trees they were supposed to. And this is kind of what the stand looks like now. And what we're doing now is kind of cleaning up the remaining debris in that stand. And then we're going to go in there and mulch the stumps down so that we can get fertility on that stand. And this fall, we'll go in there and establish our plots. Okay, so that's our initial project. Now we got some other research funded. It was called Made in the Shade, and this was from the USDA Southern SARE program, Sustainable Agriculture Research and Education. And this is a statewide program. And some of the funds are coming here to the research station to fund a graduate student here at the station to work on this project. And we've got a really good graduate student, Kelly Mercier. She's from Wisconsin, Colby, Wisconsin, actually. And she grew up on a small dairy farm in Wisconsin. So she's got a great work ethic, and she spent last summer here collecting the initial samples, and she'll be back this summer to collect more data. Right now she's at campus taking her classes. So we're very happy to have her working on this project. Kelly presented our first abstract at the American Forage and Grassland Council conference of the initial research results from our initial survey. I just wanted to recognize all the people that's involved in our Silvopasture team statewide. And again, John Fike is kind of our leader. And then I'm here at the Southern Piedmont, and Brian Campbell's on the project. And Adam Downing is from Madison County, Virginia. He's in Cooperative Extension. Greg Fry, who's went to North Carolina, was involved in the project. He was at Virginia State University, and whoever they hire in that forestry position will certainly be involved in this project. John Munsell from our forestry department's involved. J.B. Daniel from the NRCS. Jason Fisher from Halifax. And then we've got Kelly as a graduate student working on this project. And again, I just wanted to emphasize this publication. Establishment and Management Principles for Pine Forest in the Southeastern United States. Really good publication. And if you're interested in silvopastures, take the time to look it up and download it. And it's really a user-friendly publication, not written, so it's hard to understand. So with that, I'm going to finish up, and I'd like to ask you if you have questions. You're welcome to email me or call me or stop by and see me sometime. I encourage you to come back for our summer field day, and we'll take a look at the Silvopasture area. And I'd encourage you to visit with all the people on the Silvopasture team. J.B. Daniels, local. We've got Jason Fisher. We've got Kirby Wolfuck. We've got Miller Adams. All are very knowledgeable and can help you as you consider doing silvopasture on your farm. So with that, thank you for your attention. I hope you have a great conference and look forward to seeing you.